Few places on Earth appear as peaceful and picturesque as the Greek island of Santorini. To millions of visitors each year, Santorini feels like paradise. But this breathtaking landscape exists because of one of the most violent geological catastrophes in human history. Santorini is the shattered rim of a gigantic volcanic crater called the Santorini Caldera. The steep cliffs surrounding the island are actually the exposed walls of a collapsed volcano that once towered high above the Aegean Sea. Thousands of years ago, a colossal eruption tore the heart out of this mountain, blasting ash across the Mediterranean and leaving behind the vast flooded crater that now defines the island. Yet the story did not end there. Deep beneath the island, molten rock continues to move through a complex network of magma chambers and fractures, reminding scientists that the volcanic engine beneath Santorini is still alive. The Santorini volcanic system sits within one of the most geologically active regions of the Mediterranean. The island lies along the volcanic arc created by the slow collision between the African tectonic plate and the Eurasian plate. As the dense African plate slides beneath the lighter crust of southern Europe, the descending rock melts deep within the earth. This melting produces magma that rises through the crust and feeds a chain of volcanoes stretching across the Aegean Sea. Santorini is one of the most prominent volcanoes in this arc. Over hundreds of thousands of years, repeated eruptions gradually built a massive volcanic island from layers of lava, ash, and pumice. Early eruptions were relatively moderate, producing lava flows and explosive blasts that expanded the island outward. But as the volcanic system matured, magma began accumulating deep underground in increasingly large reservoirs. These reservoirs stored enormous amounts of gas-rich magma under immense pressure. Eventually, the system reached a tipping point. The magma chamber beneath the volcano grew so large and unstable that it could no longer contain the pressure building within it. When the eruption finally occurred, it unleashed a catastrophic chain of explosions that permanently altered the geography of the region. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Around the 17th century BCE, Santorini experienced a catastrophic eruption that ranks among the largest in recorded human history. At the time, the island was not the crescent-shaped landscape seen today, but a nearly circular volcanic island. The disaster began with powerful earthquakes as rising magma fractured the crust. Soon afterward, enormous explosions blasted ash and pumice high into the sky. Volcanic columns soared more than 30 kilometers into the atmosphere, darkening the eastern Mediterranean. Ash fell across nearby islands, while massive pyroclastic flows raced across Santorini itself. As the eruption intensified, the magma chamber beneath the volcano rapidly emptied. Without its internal support, the volcano collapsed inward, forming the enormous Santorini Caldera. The sea rushed into the new depression, triggering violent steam explosions as water met hot magma. The eruption expelled roughly 60 cubic kilometers of material. Ash from this eruption has been discovered as far away as Turkey, Egypt, and the Black Sea, while tsunamis struck coastlines across the Aegean. Many historians believe the disaster ended the powerful Minoan civilization. Entire communities were buried beneath thick layers of ash, preserving buildings, pottery, and artwork that archaeologists would only rediscover thousands of years later. For much of the 20th century, scientists believed the Santorini volcano was relatively simple in structure. They assumed that a single magma chamber fed the eruptions that built the islands within the caldera. However, modern geophysical research has revealed that the volcanic plumbing beneath Santorini is far more complex. Studies reveal that the volcano is fed by a series of interconnected magma reservoirs rather than a single chamber. The largest of these reservoirs lies several kilometers beneath the caldera floor. This magma body contains partially molten rock. Although the magma is not currently erupting, it remains capable of moving through fractures in the crust if pressure builds within the system. The existence of this complex plumbing system means the Santorini volcano can remain active for long periods of time. Magma does not need to accumulate all at once to produce an eruption. Instead, it can gradually move through the system over years or decades, slowly increasing pressure until the conditions for an eruption are met. Despite the calm appearance of Santorini today, the volcano continues to display signs of activity. Seismic monitoring stations across the island regularly record small earthquakes beneath the caldera. These earthquakes are often caused by the movement of magma or hot fluids through fractures in the crust. In early 2025, the region was shaken by an intense and prolonged earthquake swarm. Beginning in late January, thousands of tremors suddenly erupted beneath the sea between Santorini and the nearby island of Amorgos. Within just a few weeks, the number of recorded earthquakes climbed into the tens of thousands. Most of the earthquakes were small, but the sheer number of events alarmed both scientists and residents. Several tremors exceeded magnitude 4, and the strongest reached around magnitude 5.2. The constant shaking, sometimes occurring only minutes apart, prompted thousands of people to temporarily leave Santorini and neighboring islands as a precaution. Greek authorities even declared a state of emergency, while scientists rushed to determine what was happening beneath the seafloor. Detailed seismic analysis later revealed that the swarm was likely linked to magma movement beneath the volcanic system. Researchers found evidence that a large sheet of magma had begun forcing its way through the crust, fracturing rock and triggering earthquakes as it spread. Fortunately, the magma intrusion eventually stalled several kilometers beneath the surface, and the swarm gradually faded after several weeks. No eruption followed. Yet, the episode provided a powerful reminder that the Santorini volcanic system is far from dormant. The possibility of another large eruption at Santorini is one of the most intriguing questions in modern volcanology. The Minoan eruption demonstrated that the volcanic system is capable of producing extremely powerful explosions under the right conditions. But how likely is such an event in the future? Most scientists believe another eruption will eventually occur at Santorini. However, the majority of future eruptions are expected to be relatively small compared with the catastrophic event that formed the caldera. These smaller eruptions would likely resemble the historical eruptions that built the Kameni Islands over the past few centuries. Nevertheless, the possibility of a larger eruption cannot be completely ruled out. For a caldera-forming eruption to occur again, a massive volume of gas-rich magma would need to accumulate beneath the volcano. This process could take thousands or even tens of thousands of years. Geological evidence suggests that Santorini has experienced several large explosive eruptions throughout its history, not just the Minoan event. These eruptions appear to occur in cycles separated by long periods of relative calm. If such a cycle were to repeat, the volcanic system could eventually build up enough pressure to produce another powerful eruption. However, scientists believe that any buildup towards such an event would likely be preceded by significant warning signs, including increased seismic activity and rapid ground deformation. If Santorini were to experience another major eruption, the consequences could extend far beyond the island itself. Today, the region is far more densely populated and interconnected than it was during the Bronze Age. Santorini has become one of the most popular tourist destinations in the Mediterranean, attracting millions of visitors each year. A large eruption could produce widespread ashfall across the Aegean region, disrupting air travel and damaging agriculture. Volcanic ash clouds could drift across parts of Europe and the Middle East, affecting transportation and infrastructure. Perhaps the greatest danger would come from tsunamis generated by the collapse of volcanic material into the sea. Similar tsunamis were likely produced during the Minoan eruption and may have devastated coastal settlements across the Aegean. Modern coastal cities, ports, and shipping lanes would face significant risks if such waves were generated again. Because of these potential dangers, Santorini is now one of the most closely monitored volcanoes in Europe. Scientists from Greece and other countries operate a network of monitoring instruments across the island and surrounding seafloor. Seismic sensors detect earthquakes that might indicate rising magma. GPS instruments measure tiny changes in the shape of the island. Gas monitoring stations track emissions from volcanic vents, while satellites continuously observe ground deformation from space. Together, these tools allow researchers to detect early signs of volcanic unrest. If magma begins moving toward the surface, scientists hope to identify the warning signals long before an eruption occurs. Although another catastrophic eruption is unlikely in the near future, the volcano beneath Santorini is far from dormant. Magma continues to move through the crust, and the landscape itself remains a product of past explosions that reshaped the entire region. For now, the volcano sleeps beneath the Aegean Sea, but the story of Santorini reminds us that even the most peaceful places on Earth can hide forces capable of rewriting history.